Okay, so today I'm going to teach you our STAAR hack. So on the day of the test, you will receive this blank periodic table. So we're going to write some things on it to help us have kind of like a cheat sheet. The first thing we're going to do is we're going to draw an arrow here into this elemental symbol box, and we're going to write the word element. So that's going to let us know anytime we're looking at a chemical formula, we need to know what elements are in it or how many elements there are. We're just looking for these parts of the symbol, and we can use that to figure out which ones they are. Now we're going to turn our periodic table, and we're going to draw a line under the word underneath hydrogen, because hydrogen's not part of this category. We're going to write the word metals. Then we're going to write the characteristics or properties of metals. Metals are shiny. Metals are good conductors, which means energy passes through them easily. They are malleable, which means they can be hammered into sheets. And they are ductile, which means we can pull them into wire. Okay, now we're going to turn our paper all the way back around. And on this side of our periodic table, we're going to write the words non-metals. And we're going to write the properties or characteristics of non-metals. Non-metals are dull. Non-metals are good insulators, which means energy does not pass through them easily. They are brittle, which means they can be broken easily. They are bad conductors. All right, and now we're going to turn back right side up, and we're going to look at our metalloids. All right, so we're going to start with boron, and we're just going to draw a box all the way down. So boron, silicon, arsenic, tellurium, polonium, and back up, antimony, germanium, silicon, boron. And these are metalloids. So we're going to write metalloids. And we're going to draw an arrow. And next to that, we're going to write shared properties, because metalloids have properties of nonmetals and of metals. So if we're looking at a question and it's asking us about some things that maybe are dull but are okay conductors and are ductile, then that might be a metalloid. Okay, the next thing we're going to talk about is chemical formulas. So that we're going, on the right hand side on the bottom, we're going to write the chemical formula for glucose, which is C6H12O6. Okay, I'm going to put a 1 right here for my molecule. Okay, so the first thing I'm going to count is how many elements I have. So I have carbon, I have hydrogen, I have oxygen. So I have 3 elements. I have 1 molecule. And then I'm going to add up my subscripts. I have 6 plus 12 plus 6 for a total of 24 atoms. And next to that, I'm going to write for our molecules to help us remember. If we have a molecule, we multiply if there's a coefficient, a number at the front. And our subscripts, we're going to add. So these little numbers here, subscripts, get added, and then we multiply by the molecule. Okay, next thing we're going to do is move up to the top of our paper, and we're going to write our chemical reaction evidence. So the first thing for evidence of a chemical reaction is an unexpected color change. If I pour 2 liquids together that are clear and they turn green, that's unexpected, that's a chemical reaction. Next is an unexpected temperature change. If you remember when we did the experiment with the balloons and the baking soda and vinegar, that turned cold. That was an unexpected temperature change. A precipitate forms. That's when you pour liquids together and a solid is formed in the liquid. Next we have bubbles or fizzing. That's evidence of the creation of a gas. That doesn't include boiling. Okay, so we're going to write not boiling because that's just a change in state. Not boiling. Okay, and then smoke, fire, or burning is our last piece of evidence of a chemical reaction. Okay, now when we have a chemical reaction, we're going to use the law of conservation of mass to help us with that. So I'm going to move right over here to this blank space. I'm going to write the law of conservation of mass. So law of conservation of mass. And I'm going to write reactant yields product. So if I have 56.5 grams of something going in, then I have to have 56.5 grams of whatever the new thing is coming out. All right, now we're going to turn our paper over. First, we're going to draw our formula triangles. Right, so density equals mass divided by volume. Okay, I'm going to put my little division symbols here. So if they give me density and volume and I need to figure out mass, if I cover up mass, I can see density times volume will give me mass. If I need the density, I can cover up density, mass divided by volume. If I need the volume, mass divided by density. Okay. All right, next we have our average speed. So average speed. So speed equals distance divided by time. Put my little divisions. Okay, and then for our graphing, we're going to make an arrow. This is a constant speed. This is an acceleration. And over here, this is a stop. All right, and then for net force, we're going to do one more triangle. So if they give us mass and acceleration, we can figure out force is mass times acceleration. So you put force up here, mass here, acceleration here. If they give me mass and force and I need to figure out acceleration, force divided by the mass. If they give me, if I need to figure out mass, force divided by acceleration. Right, we can do all of those things. Or for net force, they could give us a diagram where they give us a box and we've got 6 newtons pushing to the right and 2 newtons pushing to the left. We're going to subtract. Or if we have 6 newtons pushing to the right, 2 newtons pushing to the right, we're going to add those. Okay, 0 newtons, so if they cancel each other out, that equals balanced. Then we're going to divide our paper into 6 squares. Right, in our first square, we're going to put our seasons diagram. So I'm going to draw an earth, a sun in the center, and 4 little earths going around it. Make sure you put your equator on your earth so that you can separate your hemispheres and your tilts. That's what causes the seasons in the first place. All right, and in our northern hemisphere, that's where we live. We have summer, fall or autumn, winter, and spring. In the summer, we have longer days. You get more daylight and shorter nights. And in the winter, we have shorter days, less daylight, and longer nights. And in the southern hemisphere, it's the opposite. So if we're in spring, they're in fall. If we're in summer, they're in winter. All right, our next one we're going to label as tides. We're going to draw our sun here. This is the one that has the earth in the middle. And we're going to put 4 moons around our earth. Right, when the sun, the moon, and the earth are in a straight line, that's either the new moon or the full moon. And that's a spring tide. And that has the highest highs and lowest lows. So there's a greater difference between the tides. Okay, and on the other side, when we have a first quarter or third quarter moon, so the earth, the moon, and the sun are making a right angle or 90-degree angle, that is a neap tide. Neap equals 90, that's how we can remember that. And that's when we have a minimum difference between high and low tide. Okay, moving into our second box here, we're going to talk about plate boundaries. Right, so when they're going together, we call that convergent. They're converging, they're running into each other. That creates folded mountains. When they're going away from each other, we call that divergent. And that creates rift valleys or mid-ocean ridges if it's happening underwater. When one of them slips under the other one, we call that subduction. That creates trenches and volcanoes. And finally, when they're sliding past each other, we call that transform. And we get earthquakes, faults. Okay, over here we're going to write some vocabulary to help us remember our biology. So we start with biotic. Biotic is things that are living or were once living. I like to think about zombies to help me remember that. Zombies are biotic. Abiotic is things that are non-living and were never living. Rocks, water. Then we have prokaryotic. That's a cell that has no nucleus. And we can remember pro and no. Eukaryotic has a nucleus. So U. And the nucleus stores our genetic information. So it stores chromosomes. And genes. Okay, then we have autotrophs. Autotrophs make their own food. Or heterotrophs. Hunts for food, and you can remember that because both heterotroph and hunt start with an H. Okay, moving into our fifth box, we're going to put some weather symbols. So we'll start with the cold front. Make sure that your triangles are pointy. Label that cold. Then we've got our warm front. Draw a capital H. That's for high pressure. And remember that brings kind of happier weather. So it's calm and cool. And then L for low pressure. Low pressure brings lousy weather, so rainy, warmer. And then for hurricanes, we want to remember that a hurricane is a typhoon, is a tropical cyclone. All three of those things are the same. Just depends on what hemisphere you're in. And the things that they need are warm, humid air, warm ocean water, and low pressure. Just make a note that that cold, water, and land destroys them. Okay, and in our final box, we're going to write the difference between a plant cell and an animal cell. Plant cells have a cell wall for structure. Plant cells have a chloroplasts, that's what have chloroplasts, that's what makes them their food. They have a large vacuole to help them store their nutrients. Animal cells have a smaller vacuole. Plant cells are square or rectangle shaped. Animal cells are rounded. They don't have that structure. And the final thing we're going to do is make our kinetic energy. So at the top we're going to write most PE. At the bottom of the hill we'll write most KE. PE is potential energy. That's stored. KE is kinetic energy. And that's energy that's in motion. All right, so if you can remember to put most of these things onto your STAAR reference sheet, then it will help you answer a majority of the questions and just give you that calm and confidence that you need to be successful. All right, and make sure that's what your front should look like.